This was question number 5. We quickly need to go for question number 6 and 7. So this is question number 6. So tennis ball initially moves with a velocity of 28 meter per second. So here we have a ball. It is moving from 28 meter per second to the right. A tennis racket strikes the ball. So let's say this is the racket. It strikes the ball, giving it a velocity of 28 meter per second in left direction. Treat the collision as elastic collision and the ball and the racket as particle masses. So this is 0.58 kgs and this one is 0.261 kg. So we have, does the speed of the racket change as a result of collision? So first let's look at the solution given by Junior Tutor. So we determine whether the speed of the racket changes as a result of the collision. So first we recall that the elastic collision defined as the collision wherein there is no loss of kinetic energy. So that is true. And we can clearly see that the initial and final velocity of the ball is the same but in different direction. So the speed of the racket will not change as a result of the collision. And initial and final velocity of the racket must be same. So yeah, that looks pretty much correct. And then we'll go for the B part. So in the B part it says that now we determine the total momentum of the system. So recall that since the collision is elastic, the total momentum of the system is conserved. So total momentum is basically momentum of ball plus momentum of racket small p. So I can just say this as mass of, so I'll just calculate the total momentum at final stage. So mass of the ball is 0.261 into final velocity, which is 28 meter per second, and this will be added with 0.58 kilos, and the final velocity of racket will be 0. Let me just confirm that. Yeah, so the final velocity of racket will be 0, and if I do the calculations here, so I will get 1.624 kg meter per second. So this is going to be the total momentum of the system. And in the C part it is asking for the initial velocity of the racket, so we can use the conservation of momentum principle. And here the initial momentum will be equal to final momentum, and the initial momentum of ball mt, this was vi of t, plus mass of racket, and then vi of racket is this will be mass of ball into final velocity of ball plus mass of racket into final velocity of racket. So we clearly saw that the final velocity of racket is 0, so this term will go to 0. And if I just solve, or if I just simplify this equation for VIR, so I can get VIR as mass of ball V final minus V initial over mass of racket, and this will be, so velocity in left direction will be minus, so this will be 0.261, 28 minus minus of 28 over 0.058. So I'll just calculate this. So I'll just calculate, and this will become minus 12.44 meter per second. So it is basically 12.44 meter per second in left direction, and the answer given by Junior Tutor is the same answer, so I'll just say the solution given is correct. Good work. For this question, I'll use the red pen. So actually the time for my stream is over, so I'll just end this session here. I'll just skip all these questions. So that was pretty much all for this session, and if you like this session, then please do hit the like and subscribe button also, and please do hit the bell icon also, so you can be always updated with our upcoming streams. And this was Devansh Purohit, Junior Tutor at OneClass, and if you need any tutoring help, or if you need any one-to-one live sessions, or if you want to submit your own questions, then you can check the links in the description below, and I'll see you soon in my next video. So till then, bye.